Okay, so in Chapter 6, we are going to extend the idea of graphing lines and solving equations to graphing systems of equations and solving systems of equations. So one way to solve a system of equations is to graph that system. So we've had experience graphing lines in standard form and slope-intercept form. So we're going to kind of review that today and then use those to describe the solutions to systems of equations. So our objective is to check solutions of systems of equations, solve systems of equations by graphing, and use systems to solve real-life problems. So in our first example, we're going to solve the system of linear equations by graphing and check our solutions when we are done solving by graphing. So in example 1, part A, I'm going to first graph the line y equals x plus 2. So that line has a y-intercept of 2 and a slope of 1. So I'm going to graph this, and I'm going to mark off the slope, up 1, right 1. Alternatively, if I go up 1, right 1, that's the same as going down 1, left 1. And I know I drew way more points than I really needed to, but that's just to help me draw as straight of a line as possible. So I graph the first equation in the system. The second equation in this system is y equals 3x minus 2. That has a y-intercept of negative 2 and a slope of 3, which means I count that slope from the y-intercept of going up 1, 2, 3, right 1, up 1, 2, 3, right 1. And we should see a distinct point where these two lines intersect. They intersect at the point 2, 4. So our solution to this equation is the point 2, 4. And you'll notice I said check your solutions, or I said that check your solution. To check your solution for this system, you substitute 4 for y, 2 for x. So in the first equation, that's going to be 4 equals 2 plus 2, because 4 is y and 2 is x. That is true. In the second equation, 4 equals 3 times 2 minus 2, which is 6 minus 2, which checks out. So the solution to that system is an ordered pair, a point. So 2, 4 is my solution to that system. So that's how I want you to communicate your solutions to these systems, as an ordered pair or a point. In part B, we have a different type of equation, not slope-intercept form, but in that standard form, where we'd have to find x and y intercepts. So in this equation, our x-intercept is the x value when y is 0. So the x value in that equation when y is 0 would be represented by 3x equals 6, because y is 0. So my y-intercept is x equals 2. Okay? My y-intercept of that equation is the y value when x is 0. So the y value when x is 0 will be represented by 2y equals 6. So my y-intercept is negative 3. So an x-intercept of 2, a y-intercept of negative 3 would look something like this. Okay? So to connect those points, I'll do my best to draw a line through them. So that is my first equation in the system. My second equation in the system is a simple y equals negative 3. And if we remember from last chapter, that is a horizontal line at y equals negative 3. So I'm going to draw a horizontal line at y equals negative 3, which would look like this. So my solution is the point 0, negative 3. If you want to check your solution, you substitute into both equations 0 for 3 and negative 3 for y. That works for the first equation because 0 minus negative 6 is 6. In the second equation, I just substitute my y value, negative 3, and negative 3 equals negative 3. So it checks out for both equations. So checking your solution is important in that it helps you determine whether you did the work right or not. It's a way to self-check your work. So moving ahead, I'd like you to work through some guided practice now. So pause the video, work through these two examples, and then resume the video when you are ready to move forward. You'll see the answers, and you can move on to example 2. Okay, so the solutions to each of these. For number 1, the solution was -2, 0. And for number 2, the solution was -2, -1. So the solutions to each of our systems of equations. So make sure, and I'll clean up my line for the other one, but just make sure you're graphing these carefully, following the steps I'm laying out in these notes. Make sure when you're taking the notes that you're writing everything out so that you can reference this when you're going through the practice, when you're going through the checkpoint, when you're studying for the quiz. So in example 2, what we're doing is we're writing a system of equations from a scenario or modeling using a system of equations. So this example talks about scientists studying the weights of 2 alligators over a period of 12 months. The initial weight and growth rate of each alligator are shown below. After how many months did the alligators weigh the same amount? So for alligator 1 and alligator 2, we have to write equations. So for alligator 1, we have to understand this situation is where we have an initial weight and a growth rate. So we have a situation where y equals mx plus b, slope-intercept is probably appropriate. In this situation, the slope, the growth rate is 3/2 of a pound per month. I'm just taking the 1.5 and converting that to a fraction, 3/2, because a slope is easier to count when it is a fraction. And then the initial weight would be our y-intercept, or starting value, 4. So our equation for alligator 1 is 3/2 x plus 4. Okay, 3/2 x plus 4. For alligator 2, same, y equals mx plus b. The growth rate, the slope, is going to be 1 pound per month. The starting value, the y-intercept, is 6 pounds. So our equation is x, or 1x, plus 6. So I have my equations. We've had practice graphing these types of equations, so we can move ahead to graphing alligator 1's weight over time. So I'm going to graph the y-intercept of 4. And the problem here is that when I count my slope, I'm going up 3, right 2. And there's no mark for 7, so I've got to estimate. So I go up 3, right 2. It's about right here. If I go up 3, right 2 again, to go up from this point to 7, I'll go up 3 from 7, which is up to 10, and then right 2. Okay? And then up 3, right 2 would look like this. Up 3, right 2 again would be right about here, which isn't going to be as important at the end. But it's important that I draw this line not going to the left of 0, because the alligator's weight can never be negative. Okay. For the second alligator, I start at a weight of 6, and I go up 1, right 1. So up to 7 over to 1 month. At 1 month, it's 7 pounds. At 2 months, it's 8 pounds. At 3 months, 9 pounds. At 4 months, 10 pounds. So this is where our equations intersect. So it's important that we're precise with what we're doing. So after how many months do the alligators weigh the same amount? We would say at 4 months, both alligators weigh 10 pounds. I'll do a better job of writing that. Weigh 10 lbs, 10 pounds. So the graphing is important, and sometimes the graphing is not perfect. So we have to use some logic to think about what is an answer that makes sense. Are we counting this the right way? Are we using good estimation strategies to determine where these alligators' weights match up? Now, I know number 3 says guided practice, and really number 3 is where I'm going to leave this video. You're going to do example 3, the next example, in a different video. But I'm still going to go through number 3, so stick with me through this one. This one is a little bit easier, I think, to set up the equations. It has 2 satellite radio services. One charges $10 per month plus an activation fee of $20. So we have service 1. It has a rate of $10 per month. It has a starting value of 20. So my equation is going to be my rate, $10 a month, 10x, plus that initial starting value of 20. The second service charges $11 per month plus an activation fee of $15. So service 2 has a rate of $11 per month, so I would do y equals 11x plus that starting value of 15. This one I think is a little bit tougher. That's why I'm not making you do this one on your own. So to graph this one, service 1 is easier to graph because I have starting value of 20. For my slope, I go up 10, right 1. And up 10, right 1 is relatively easy to graph on this grid because it goes up by tens. So draw that the best you can. Now the second one is tougher, but we've got to use some logic here to figure out, and I'm going to make a table for the service 2. We start off with a y-intercept of 15, and we know the rate of change is 11. So that means every month of service, I get charged $11 more. Okay? I get charged $11 a month. So in month 1, I'd be charged, for 1 month, I'd be charged $26 total. For month 2, $37 total. Month 3, $48 total. Month 4, $59 total. And then month 5, $70 total. That helps me because the graphing on here is not an exact science. You are going to have to estimate 126, 237, 348, 459, and then 570. That's the only easy one to graph. But if you're not careful with how you graph, this could get really tricky because these lines are very, very close to each other. So, in what month was the cost of the service the same? In month 5, both services, I'll write that better. Both services cost a grand total of $70. So this one's harder because the graphing is so close that you have to be precise with where you are finding the points and where you are estimating where the points lie. But it's understanding that rate of change only takes you up $11 a month. So you don't hit the other service until month 5. So that's about long enough for you to take notes for one sitting right now. So you're going to move on to the practice and some other things. You're going to come back to this after you work on some practice. Then you do just example 3 in one video, and then you can move on to the checkpoint once you are ready. But this is a longer set of notes because it is new and it is more complex than other things we have covered because it's 2 things at once. So move on to the practice, work through that, and then when you're ready, you can move on to the next part of this video.